Today, we're going to peel back the curtain on how a professional AI forecasting system, SPECTRA AI, actually learns. We're going deep inside the Gambler's Ruin project, and we use just 1 week of data to see how these incredibly complex models get better not just from their wins, but, and this is the important part, from their losses.
And this quote right here, it just sets the tone perfectly. This is not about celebrating what the AI got right. Nope. This is a tough, transparent breakdown of every single prediction, the good and the bad. This is the real, gritty work of building a sophisticated model. It's a full-on accountability audit, and it's how you build a genuine long-term edge.
So, here's our game plan. First, we'll get our heads around the audit itself. Then, we'll dig into the hard evidence from 5 key matches. After that, we'll start connecting the dots to find the hidden patterns, check out the surgical fixes they rolled out, and finally, we'll talk about how all this painstaking work builds a real, sustainable advantage over time. Okay, let's get into it.
First up, the accountability audit. Now, the key thing to remember here is that we're only looking at 1 week of data, but this isn't about 1 week's profit or loss, not at all. It's about treating every single week as a crucial piece of the puzzle in this long, iterative journey of building and refining a seriously robust AI model. This is how the pros do it. So let's get to the evidence. This particular week was, as it turned out, the perfect stress test for the model at the time, version 8.16. See, the goal wasn't to get every call right. It was to push the model, to put it under real pressure and see where the cracks start to show. And wow, the data we got back was incredibly useful.
So here's the scorecard at a glance. The model got the right outcome in 3 out of 5 games. That's 60% accuracy. But the really juicy stuff is in those Breyer scores, which basically measure how good the model's probability predictions were. An average of 0.65 is okay, but a worse score of 0.78, that tells you there's a big story hiding in these numbers. This data, even though it's not perfect, is pure gold.
All right, first matchup, Juventus versus Roma. The model called a home win, and yep, Juventus won 2-1. On the surface, this looks like a slam dunk. The AI picked the winner, and the final score was right up there with its most likely predictions. A nice, clean, high-quality call.
But this is where it gets really interesting. Even in a win, this flaw showed up. The model was underconfident. It wasted too much of its probability on the game being a draw, which made its correct prediction weaker than it should have been. This is our very first clue to a system-wide issue we're going to call draw inflation. The football brain is working, but the math is a little nervous.
And now, for the first big miss of the week. The model had a slight lean toward Crystal Palace winning away. The final score? A thumping 4-1 victory for Leeds at home. Whoa, this wasn't a near miss or bad luck. This was a major error, and honestly, a fantastic learning opportunity.
And this number just screams how big of a miss that was. A Breyer score of 0.78. That is super high. A score like that tells you this wasn't just random chance. It points to a genuine, fundamental blind spot in the model's logic.
So, why did it get it so wrong? Well, the audit uncovered 3 things. 1, it put way too much stock in historical team ratings. 2, it totally underestimated the motivation of a team fighting for its life to avoid relegation. And 3, it didn't properly factor in a bunch of injuries at Crystal Palace. It's a classic contextual blind spot, and it gives the developers a crystal clear target for the next upgrade.
Next, we've got a 2-2 draw between Newcastle and Chelsea. The model called a draw, so technically it was right, but you see that little warning sign? This was what we'd call a correct but soft prediction. Again, while the draw was the right call, the model spread its bets too thinly, hurting its score. It was right, but it kind of whispered the answer instead of shouting it.
The Tottenham versus Liverpool game was another one of those quiet successes. The model correctly called the away win, and all the underlying data backed it up. But, you guessed it, that same old problem dragged its score down again, draw inflation. This match is a textbook example of why the model needs a new rule to dial back its love for the draw in certain games.
And here is our second major miss. The model leaned toward a home win for Wolves, but Brentford walked away with a solid 2-0 victory. Now, this loss was really different from the Leeds game. This one exposed 2 completely separate structural problems in the AI's architecture. And would you look at that Breyer score, 0.78. Exactly the same high error number as the Leeds match. When you see a pattern like that, you know you're onto something big. 2 different games, 2 different reasons for the miss, but the exact same size of error. That's a huge signal of an underlying flaw.
So what went wrong here? First,
The model was just way too confident in home teams that were struggling near the bottom of the league table. Second, and this gets a bit technical, one part of the model, the artificial neural network, was basically shouting down the other parts of the system with way too much confidence. This one single match gave the team all the justification they needed for several key changes in the next update.
Okay, so we've looked at the individual trees. Now it's time to step back and see the whole forest. Let's connect the dots. We've seen the wins, the big misses, the near misses. Now comes the real work, putting it all together to find the system-wide recurring patterns.
And when you lay it all out, 3 really clear patterns just jump off the page. Number 1, the probability for draws is just too high across the board, making the model timid. Number 2, it's got way too much faith in bad teams when they play at home. And number 3, that artificial neural network sometimes just goes rogue and destabilizes the whole prediction.
Now, listen up because this is probably the most important takeaway from this whole thing. These are not fundamental problems with understanding football. The model's core logic, its football brain, is totally sound. These are calibration and weighting problems. The AI gets the sport, it just needs a little more discipline in how it does the math, and that is a very solvable problem.
Which, of course, brings us to the prescription phase, the surgical fixes. Based directly on those patterns we just identified, the team developed a set of very specific, targeted solutions that went straight into the next version of the model, v8.17.
And here they are. To deal with that overpowering neural network, they put a cap on how much weight it can have. To fix the home bias, they're adding a specific correction for those relegation zone teams. And to kill that draw inflation, they're adding new logic to shrink draw probabilities when it makes sense. You can see it, right? A direct line from every problem we found to a specific targeted action. These are surgical fixes, not a complete overhaul.
So let's zoom out and look at the big picture. This all brings us back to the core philosophy of this whole project, building the long-term edge. This disciplined, constant cycle of test, diagnose, and fix week in, week out, that is how a real, sustainable advantage is built over time. It's truly a never-ending process of improvement.
And of course, it never stops. So the next logical question is, okay, after these fixes are in, what's next? Well, the plan for version 8.18 shows the evolution is just getting started, with a brand new focus on something they're calling context intelligence.
And this is where things get really, really cool. We're talking about adding modules that can understand a specific referee's tendencies, a dynamic index for team motivation. Are they fighting for a title or just playing out the season? They're even working on a proxy for home crowd intensity. This is all about adding those deep layers of real-world context that go way beyond the basic stats.
And we're going to end on this powerful idea, the one that really guides this entire project. Real progress, the kind that lasts, doesn't come from defending your work and showing off your wins. It comes from relentlessly testing it, actively hunting for its flaws, and having the discipline to fix them over and over again. Because in this project, the model doesn't get defended, it gets tested. And that, right there, is how you build something truly exceptional.